Hi. So today I'm going to be giving a lecture on the history of the internet, which is the first lecture here in MI238. So the internet developed in the late 50s and developed in tandem with communication networks. And this involved technological developments and the merging of existing network infrastructures and telecommunication systems. And usually these began in Western countries, but eventually it trickled down to developed and developing ones. In the early 50s, communication networks were limited physically to allow communications between stations on the networks. And this was done using bridges or gateways. However, the distance usually was limited. And during this time, computing was consisted of central mainframes, which is basically one computer that's connected uh, to terminals using leased lines or telephone lines. Now, before I continue, I'd like to give some definitions of some terms that might be mentioned as I during the lecture. So we have bridges, which are basically instruments that connect multiple network segments together. There are also gateways, which is a computer or a network that allows or controls access to another computer or network. I'll be talking about this more later on as we uh, go through our other lectures. And then the last is the node, which is a device that is connected as part of a computer network. It can be a PDA or it can be a PC or any device that's basically connects to the network. Now, in 1958, there was an agency that called the Advanced Research Projects Agency that was developed in the US. Now, the goal of this agency is to advance military research. And remember, this was during the time of the Cold War. Now, J.C.R. Licklider was the head of the Info Processing Office at this time, and ARPA had developed three terminals using connecting to a mainframe. The first one was in Santa Monica, the second in the University of California, and the third was in MIT. And all three terminals used three different sets of commands. The goal of ARPA was to create a worldwide network that would monitor and control weapons located in different parts of the world. ARPA reported directly to the U.S. Department of Defense and developed state of the art technology in order to maintain the leading military research position. Now, early models of network computers were telephone companies, which used circuit switching. For those of you who are familiar with TV shows in the 80s or in the past, usually this involved switchboards wherein there will be these cables that were connecting two people together, as in literally. You just have this one cable that would be connected to the switchboard, and eventually you'll be contacted by the person on the other end. It's difficult to explain actually. Just go to your favorite search engine and type what and look up circuit switching. However, this type of switching required or created dedicated connections between computers. So naturally, there would be problems also with these types of switching, but I'll talk about that later on in the email lecture. Now, Donald Davies, Paul Baran, and Leonard Kleinrock developed the concept of packet switching. And this was developed from studies of decentralization to avoid combat damage compromising the entire network. Naturally, since they wanted to come up with a system to control their weapons, they didn't like the idea that if one connection was broken, they would lose access to all their missiles and all their weaponry. Now, initially, the ARPANET, or this network, consisted of only four nodes. Now, these nodes were connected using AT&T lines, which were 50 kilobits per second. Remember, this is kilobits. The first node was in UCLA, the second was in Stanford, the third was in University of California, Santa Barbara, and the fourth was in the University of Utah. And here, as you can see, the geographic positions of these nodes were on the west coast of the USA. Now, eventually, as time went on, more and more nodes were included, and as you can see here in the slide, there were connections already to the to the east coast. By 1981, the number of hosts had grown to 213, with a new host being added approximately every 20 days. Now, the father of the ARPANET was Larry Roberts. Just something nice to know. Don't worry, there's no exam. Just take note of this haircut. Now, that was the network being developed in the U.S. Now, in Europe, they were developing their own network called the X25 network, which used packet switching technologies. Now, in 1974, the X25 network was used in the CircNet network between British academic and research sites. So here, the use or the purpose of the network wasn't necessarily military. It was more on education. Now, the IPSS, created in 1978, was the first international packet switch network between the British Post Office, Western Union, and TimeNet. And in 1981, it expanded from Europe and the US to include Canada, Hong Kong, and Australia. In the 90s, it provided a worldwide networking infrastructure. Now, the features of the X25 network was that it was available for business use. It would be used for the first dial-in public access networks such as CompuServe and TimeNet, where in 1979, CompuServe offered the first service to offer email, and a year later, they offered real-time chat. Also, in AOL, Prodigy dial-in networks were X25 networks. Also, the BBS network. Now, another network that was being developed used the technology of UUCP, or Unix to Unix copy. This allowed remote connections to transfer news and data. In 1979, Tom Truscott and Jim Ellis used Bourne shell scripts to transfer news and messages. And this technology spread quickly because, for one, the software was publicly released, it was cheaper, and it had the ability to use existing leased lines or ARPANET connections. So they didn't have to develop new connections for this type of technology. This created net gateways between FidoNet and dial-up BBS hosts. And in 1983, UUCP hosts grew to 550. And eventually it ballooned a year later to 940. Now, Robert Kahn recruited Vinton Cerf, but before I continue, at this the name of ARPA had actually changed to DARPA, which is Defense ACIRPA. Parang they just added D. And actually, the name had varied from DARPA to ARPA every so often. There's actually a record in it on the internet. And the goal here was to merge the network. Since you have now all these networks that all spoke different languages, there had to be a way in order to unify them, such that you can have different technologies or different underlying technologies, and somehow you can, from the front end, from the user end, you'll be able to somehow connect to the other networks. And their solution was to hide the differences between network protocols using a common inter-network protocol. This would reduce ARPANET's responsibility for maintaining network reliability by transferring this to the hosts. And also, it became possible to join almost any network, since now, from the front end, you can type anything you want or use certain commands, and any network would understand you. So in July 1977, the precursor TCP/IP software was tested. I'll tell you more about TCP/IP later. And in 1982, all ARPANET links were converted to TCP/IP. And on January 1, 1983, TCP/IP protocol became the only approved protocol for ARPANET. And January 1, 1983 is considered the birth of the internet, actually. Now, later on, since the Cold War was more or less winding down, the ARPANET was transferred to the Defense Communication Agency in July 1975. And in 1984, MILNET was created. And the NSF, the National Science Foundation, developed the successor to ARPANET and developed the first one using TCP/IP. And also worked on the SF net backbone in 1986. Now, as time went on, more and more networks, more and more areas, more and more countries started connecting to the networks that were earlier created. And then eventually, naturally, as you can see from the slides, as time went on, more and more countries became connected in one way or another to the backbone of the internet, or constituted the backbone. Now, for commerce, there are differences between the three types of network. Because ARPANET, first of all, had restrictions to commerce. Remember, it was meant for defense. So, they wouldn't have any code specifically to address commercial activities. The other two did not have such restrictions. And in the late 1980s, the first ISPs were created. Then PSINet, UUNet, Netcom, Portal Software were formed and provided alternate network access, and the UUCP-based email and Usenet News. The first dial-up ISP, world.std.com, opened in 1989, and ISP brought down prices, allowing other schools to connect for research. So eventually, the ARPANET by the 1990s was replaced by newer technologies and closed down. And in 1994, NSFNet was renamed to ANSNet and lost its standing as a backbone of the internet. Naturally, by this time, it had already outgrown itself, and its importance became limited. And then regional network access points became primary interconnections between many networks. Now, Ray Tomlinson invented email in 1972 and introduced the use of the @ sign. In 1973, studies show that email composed 75% of the ARPANET traffic. And Elizabeth II sent an email over ARPANET in 1976. And in 1976, ARPANET began sending packets via satellite. So it was already really going beyond its primary use. Now, although in the slide it says new uses of networks, these services are actually already old and some may not even exist. But some are still relevant today. First, it's the File Transfer Protocol, which is FTP. I'm sure you're familiar with it. As for Telnet, maybe some of you are not familiar with what it's all about. Now, mailing lists, well, we already have different types of mailing lists now, and probably uses different protocols. We have Usenet, news groups, and games. Now, here's an example of us. In this slide, you can see the example of the T3 network, where you can see that if any line is cut, there are redundancies to get instructions out to, or files to be sent to other areas. Now, the Ethernet, which is something that you're popular with, although I think nowadays, as you're listening to this, chances are you're listening to this video, or sorry, you're watching this video using a wireless connection. However, before wireless became a big hit, we were all using local area networks or using the Ethernet specifications. Now, this was very popular in the 1980s, especially in universities. And many workstations in a LAN were connected by Ethernet, and this was developed by Bob Metcalf. Actually, if you think about it, if you're right now at home, you can look at your router, and if your router is not from PLDT, chances are your router is connected using the Ethernet specifications, and it's connected to the old style DSL modem. So you're actually using the Ethernet right now. Now, the WWW was created by, or the World Wide Web was created by Tim Berners-Lee and Robert Kaliau at the European Laboratory for Particle Physics in 1991. The WWW is a system of hyperlinked HTML documents. However, it's possible that its definition has evolved as time went on. Now, as for browsers, the thing you're using to view this video, unless you're using an iPhone or an Android, or maybe even a BlackBerry phone, chances are you're using a browser. And Mosaic was the one that was first developed. It was a graphical web browser or a www client, which was released by Mark Andreessen at NCSA in the University of Illinois in Urbana-Champaign. And in 1994, Mark Anderson and Jim Clark worked together to develop Netscape. And in 1996, 75% of users use Netscape. I, for one, remember using Netscape. Chances are some of you might not have even been born when Netscape was very popular. But it was eventually bought by America Online in 1999 for 10 billion in stock. However, I doubt anybody uses Netscape nowadays. Now, I'd just like to talk about the internet worm, which is, well, naturally, as people became more connected, eventually people found ways to use it for less than noble purposes. However, in this case, this person in 1988, Robert Morris, he wanted to create a experimental self-replicating, self-propagating program called the worm. Now, his goal was basically to somehow map the network. So once the software found another computer, it copied itself to the other computer. However, and then when it reached the other computer, it would then do the same thing. So somehow it would map. Its goal was to install itself into many computers. The problem was there's nothing to stop it from infecting. Sorry, not really the word infecting. There's nothing to stop it from transferring itself to another computer that already had it. So naturally, this will snowball. Eventually, you'll have computers running multiple copies of the same program. So, and naturally, this would create problems because computers will eventually slow down because the memory would be eaten up by this worm. And at that time, Morris was sentenced to 3 years of probation, 400 hours of community work, and a fine of $10,050. Now, who governs the internet? The answer actually is nobody. You have several boards that are mandated or are assigned or decided that they'll be doing the regulatory functions for certain internet related activities or standards. So you have the Internet Architecture Board, the Internet Society, the World Wide Web Consortium, the Internet Network Information Center, the Internet Engineering Task Force, and the Internet Assigned Numbers Authority. You can search more about these topics in actually where else but the internet. So this is the last slide for this lecture. Please stay tuned for the other lectures in a while.